All right, today we're going to look at surface area of pyramids and cones. So we will only be doing, as far as pyramids are concerned, when we're doing surface area, we'll only be doing what are called regular pyramids. A regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles. So, do I have one over here? No, I'll get one out in just a minute. So when you think of, again, when you think of, for example, Egyptian pyramids, they're square pyramids, they're regular. It doesn't matter which face you look at, they're all isosceles triangles. Someone told me once that they were equilateral, and I'm like, I'm not sure I believe that, but I need to look it up. So there are two different heights that are going on in this figure. So the altitude or height of the pyramid is as if you were up here at the peak and you had a pole, like a fireman's pole down the middle, and went down the middle like that, right? Inside. The slant height is the distance from the vertex to the midpoint of the base edge. That would be like if you're up here, but you were to, walk down the steps on one of the Mayan pyramids or something like that. That's the slant height. So this is the quickest way to the ground, and this is, down the middle of this lateral face. Why is that important? Well, this height is going to have to do with the area of this triangle, isn't it? The altitude, this height, has nothing to do with the area of that triangle directly, at least. So, for a regular pyramid or for a cone, the lateral and surface area given by lateral area is equal to half perimeter times the slant height. So we still want to go all the way around the pyramid, but as we're going up the sides, if we were painting the sides of the pyramid, are we going straight up any longer? If you were painting the sides of a pyramid, you're not going straight up. You're going up at an angle. That's why it's the slant height. And the reason it's half is because, well, what are the lateral faces in a pyramid?
Triangles.
They're triangles. That's where the half comes in. And then the surface area is the lateral area plus the area of the base. So let's do some. Find the lateral area and surface area for each regular pyramid or cone. All right, so here, again, I suggest you always start with the base. You don't necessarily have to draw it every single time, but it's not a bad idea. So while I'm doing this, I don't look at the three-dimensional figure at all. I just look at this, the perimeter. Well, there's 4 sides at 12 each is 48. The area of the base is base times height, and this is why I don't look over here. The height of the pyramid is something else entirely. The height of the square is 12. So this is 12 times 12 is 144. Then the lateral area is 1/2 because they're triangles. Perimeter of the base, because we still want to go all the way around, times when we go up, we're not going straight up, we're going up at an angle, the slant height. So that's 1/2 of 48 times, now the slant height on here is 18. 360, is it 432? Thank you. And the units were meters, so this is square meters. And then the surface area is the lateral area plus, unlike our prism where there were 2 bases, here there's only 1 base. So it's the lateral area plus the area of the base. So it's 432 plus 144 is 576 square meters. So that's a real straightforward problem. Again, I think it's better if you deal with all the things you need to find about the base first, and then you're just substituting into the formulas. So a regular hexagonal pyramid with a base edge length of 6 centimeters and a slant height of 10 centimeters. All right, so they didn't draw the picture this time, but I can draw a hexagon. Each of these sides is 6. So the perimeter, there are 6 sides at 6 each, is 36. The area of our base, and this is the base, it's a hexagon, so it's 1/2 apothem times perimeter. So I got to figure out what the apothem is. I already know the perimeter. Anybody remember what the central angle is for a hexagon? It's 60, so each of these little angles is 30, if that's what you were thinking. So this is 3, and this will be 3 square roots of 3. So it'll be half of 3 square roots of 3 times 36. Half of 36 is 18. 18 times 3 is 54, so that's 54 square roots of 3. So then the lateral area, we still want to go all the way around, so we're going to use the perimeter, but it's a triangle, so it's going to be half the perimeter of the base, 36, times the slant height, which was given as 10. So it's 180, and the units were centimeters, so that's square centimeters. The surface area is the lateral area plus, we only have one base, so it's 180 plus 54 square roots of 3. I cannot combine unlike terms when I'm adding, so it's just that square centimeters. All right, let's do a cone. So my base is just a circle with a radius of 5. The circumference is 2 times pi times the radius. So that's 10 pi. Area of the base is pi times the radius squared. It's 25 pi. So the lateral area is 1/2 of the circumference. We still want to go all the way around, times the slant height, because we're not going straight up while we're painting the sides. And this is the first time we've had to do something other than just fill things in, because we don't have the slant height yet. But those two meet at a right angle, so what is the slant height going to be? 13. So that's 1/2 of 10 pi times 13 is 65 pi square feet. And then the surface area is the lateral area plus, there's only one base in a cone, so that'll be 65 pi plus 25 pi is 90 pi square feet. All right, we're going to work this problem out, and then we're going to figure out a way to do it that doesn't take us nearly so long. Fair enough? So, it says the radius and the slant height of a cone are tripled. Describe the effect on the surface area. So I'm going to find the surface area of this first. So my base is a circle with a radius of 3. Circumference is 2 times pi times the radius. So it's 2 times pi times 3 is 6 pi. the base area is going to be pi times the radius squared. So it'll be pi times 3 squared is 9 pi. Lateral area is circumference times the slant height, but it's only half, again, because this is like a triangle. So that's half of 6 pi times 5. It's 15 pi square centimeters. And then the surface area is the lateral area plus, we've only got one base. So it's 15 pi plus 9 pi is 24 pi square centimeters. Now, since we're going to triple everything, you might think that the surface area is going to be tripled also. In fact, it is not. So let's draw this tripled. God bless you. God bless you. So on my new one, the radius will be 9 centimeters, and the slant height will be 15 centimeters. So my circumference is 2 times pi times the radius. It's 2 times pi times 9 is 18 pi. The area of the base, pi times the radius squared. So it's pi times 9 squared is 81 pi. So the lateral area is half of the circumference times the slant height. So it'll be half of 18 pi times 15. Let's see, 9 times 15 is 135. Square centimeters. And the surface area will be the lateral area plus the area of the base. So that'll be 135 pi plus 81 pi. See, that's 6, that's 216 pi. So if I compare, I'm sorry, square centimeters. If I compare 216 square centimeters to 24 pi square centimeters, you can use your calculator, but I already know it's 9. And you're like, wait a minute, everything grew by 3. Why didn't the surface area grow by 3? Well, area is what kind of units? Square units. All those lengths are just regular units, right? What happens when you square 3? You get 9. You don't have to, and your book asks some questions about this, you don't have to work them out. If you want to, you can, to prove it to yourself. But you can just go, okay, it's an area. If all the lengths increased by a factor of 3, then the area is going to increase by a factor of 3 squared, which would be 9. How much do you think the volume would increase by? 27, because it's 3 cubed, because it's cubic units. Okay? All right. Let's find the surface area of this composite. So for the surface area for this, You always need a plan for surface area. It's going to be the lateral area of the cone. Can I touch the bottom of the cone on this? No. Plus, can I touch the sides of the cylinder? Yep. And can I touch either of the bases of the cylinder? Just one of them, just the one on bottom. And this is where you're like, wait a minute, I used C for everything because it was cone and cylinder. That's a bad idea. CO, CL, CL. So I need to go ahead and figure out, all right, I've got this circle. I always go back to that where this is 28. So the circumference, and it's the same for the cone as it is for the cylinder. It's 2 times pi times the radius. It's 2 times pi times 28 is 56 pi. Hello. And then the area of the base is pi times the radius squared. So it'll be pi times 28 squared. I don't have that one memorized. It ends in a 4, but that's all I remember. It's less than 900. 784? Thank you. So for the lateral area for the cylinder, for the cone, it'd be 1/2 the circumference of the base, which is 56 pi, times the slant height. They didn't give me the slant height, did they? Draw a little right triangle here. That's 28. Is that y'all's bell? Yeah. Oh. Do the Pythagorean theorem to find the slant height. Okay. All right. Tonight's assignment is in the book. And y'all have a great day.